In the last video, we went through box and whisker plots, and we're going to continue to do that, but I don't think that the keystone is going to necessarily require you to make a box and whisker plot. It might ask you, like, what's the interquartile range of a set of data, which would require you actually to find the 5 numbers. So if a question says, what's the interquartile range of the set of data, you would have to find the minimum, the maximum, the median, Q1 and Q3. You wouldn't actually have to make one, like actually physically draw the box and stuff like we would see here with these problems, but it's very likely that they will ask you what's the IQR, and therefore you'd have to find the 5 numbers and then subtract Q3 minus Q1. So I'm going to skip that, but it is likely that the keystone will give you several box and whisker plots along the same number line and then ask you questions about it. So I think it's important to show an example of like a triple box and whisker plot and go through some of the questions. So a triple box and whisker plot or a double box and whisker plot is basically going to just be multiple box and whisker plots along the same number line showing data for different things. So we're showing average temperatures for 3 cities, Seattle, San Antonio, New York, and then just different questions. What's the median for Seattle? So you would go to the Seattle one. The median is, I can see this is the median, this is 59. Which city tends to have a higher overall temperature based on the plot? Now this one is interesting. So which city tends to have higher overall temperatures based on the plot? So when you're looking at this, you'd have to understand like the percents of the box and whisker plot. Like if we're looking at San Antonio, we can see that it's shifted to the right more than Seattle and New York. And if you're looking at like the different values, of course, like 61 is the minimum, which is like, you know, less than 63, which is the median in New York. New York has a high of 85 here, which is like kind of similar to some of the data values in San Antonio. But if we're looking at the percents, like 50% of the time, San Antonio is 81 degrees or more. So that's not the case in Seattle. That's not the case in New York. So based on that, I would say San Antonio. Of course, they also do have the highest maximum, and they have the highest minimum as well. Which city has the smallest interquartile range? So you could mathematically find all of the actual ones by doing 69.5 minus 51.5. So this one has an interquartile range of 18. 90.5 minus 69 for San Antonio is 21.5, and 78 minus 46.5, 31.5. So we're looking for the smallest one. You also can be able to tell from just the box. If the box is smaller, then it has a smaller interquartile range. If it's larger, it has a larger interquartile range. I just wouldn't really be able to look at Seattle versus San Antonio and say which one looks smaller because they're pretty close, but definitely the smallest would be Seattle. Which city has the largest interquartile range? Well, that would be New York. And then this question here, which city has less variability in its average temperatures and why? So variability is a vocabulary word in math when we're looking at data displays, and variability really just represents, like, I know it's bad to use the word in the actual definition, but how a data set varies means like how different are the numbers from each other. Like if I was to survey all of you in class and ask you one question, what is your age? The variability wouldn't be very high because you're all about the same age. But if we, surveyed you and invited a couple of teachers into the room as well and asked them for their ages, then that would make the data vary more because we would have some higher numbers in there, and it would just make the box and whisker plot have some outliers in it, which makes it more varied. So if I was looking at variability, what I'm looking to find is like a box and whisker plot that has, first of all, a large IQR, so a large box. That means that 50% of the data is pretty varied, and I would be thinking, looking at the options here, New York would be the case. I'd also be looking for a large range, the largest number minus the smallest number. So 85 minus 38 is 47, and the rest of the ranges, 95 minus 61. So the range for San Antonio is 34. The range for Seattle, 74 minus 46 is 25. So New York also has the largest range, and it has the largest interquartile range. So that New York would have the most variability. So this question is, which one has the least variability? So the answer would not be New York. New York is definitely the city that has the most variability. All right, so then we would be looking at Seattle versus San Antonio. So Seattle has the smallest box, and Seattle also, let's see here, 74 minus 46, has the smallest range. So because of that, Seattle would be considered having the least amount of variability because 50% of its data, is pretty close in numbers. It also has the smallest range of only 25 degrees difference between the highest and lowest. So that is basically box and whisker plots. There are tons of other questions and situations, but we pretty much covered it all. So we're going to move on. Skipping a lot of this stuff. It's so much practice, and if the test, made you do some of this stuff by hand, we would do it, but I think that that's enough as a refresher. But the test will have stem and leaf plots, so it's important for me to cover this as well. Stem and leaf plots are plots that we use to display data, and they come in a certain form, and it's very important for you to be able to read them correctly. The stem over here on the left represents the first digit or digits of numbers, and then the leaves to the right are always the last digit of the number. There will always be a key. The key will tell you how it is being read. We're dealing with test scores here. So it's telling us that the stem number to the left, whatever digit this is, and then to the right of that, the leaf number, they get combined together, making it like, for example, 7, and then line 2 would be 72. So it doesn't have to be like that. The key can be like 7/2 equals 7.2 or something like that. So you do have to read the key really well to be able to understand what's going on here. But this is how this is working. So if it's asking for the highest and lowest score, that one's pretty easy. The lowest score would be 52. So your lowest stem number with your lowest leaf would be the lowest number, so that would be 52. But the highest would be 99 with the highest leaf here. So 96 would be the highest. Which one occurs most often? What you can do is look at the leaves and look for in each row which one occurs the most. I see 3 4s here, and I don't see any other digits occur that many times. So this would be 74 occurs the most often. In which 10-point interval did most of the students score? So we're looking for in the 50s, 60s, 70s, 80s, or 90s did most of the students score, and that would be in the 70s because we can see most of the leaves are there. How many students scored 70 or better? That would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. How many students scored less than 70? That would be 1, 2, 3, 4, 5, 6, 7. All right, so that's just a stem and leaf plot, kind of how to read them. If a question ever asks you to find like the median or something like that, when it's in stem and leaf form, I actually do recommend taking each and every number and writing it out. So the question didn't ask us to do that, but 52, the next one, 54, the next one is 56, the next one is 58, and then the next row would be 61, 65, 68, and so on. So if a question asks you to find the mean or to find the middle, my suggestion would be take it out of the stem and leaf plot, write the numbers out in order from least to greatest, and then go from there. Now, sometimes we can have a stem and leaf plot that is considered back to back, and that's when the stem is actually in the center and the leaves are going in the opposite direction. So this one's about humidity in the morning versus the afternoon. So we would read this backwards. Kind of weird the way that this is set up, in that to the right, it's representing 51. So 5/1 represents 51 degree or 51% humidity. But if we're looking at this one here, 4/7, which is right here, that actually represents the opposite, 74. So you have to read it backwards. So very, very, very important to read it correctly. Reading it to the right is that way, reading it to the left is backwards. So what is the highest morning humidity? So the highest would be 89. What's the lowest afternoon humidity? That would be the first one I had circled, 51. Does humidity tend to be higher in the morning or in the afternoon? And for wherever we are, for whatever reason, the humidity is definitely going to be higher in the morning. The higher numbers are occurring in the morning. So those are stem and leaf plots. Reading the key, understanding how the key works, reading the numbers, super important. You won't have to make one, but they might give you data and ask you a question about the data when it's in this stem and leaf plot. And then the last type of data display that we need to make sure we cover again is histograms. So they might give you a histogram, like a bar graph like this. And a histogram is a bar graph. You will see bars. But the bars specifically connect at the bottom. And they connect because they go by intervals. Like this is 51 to 60. We're looking at algebra test scores, 61 to 70. So like the numbers are directly next to each other. That's why the bars connect like that. And they're pretty easy to read how many total students took the test. Like 2 students got this score. This would be 5. This would be 8. This would be 12. And this is 6. So we would just add up all those numbers together. 2 plus 5 plus 8 plus 12 plus 6 gives me 33. How many students scored at least a 71? So these scores are 71 to 80, and then all of the above, 8 plus 12 is 20, plus 6 is 26. And then can you determine the highest grade from the histogram? No. Histograms do not give you the highest or lowest grade because it tells you always an interval. Like we know that 2 students got between a 51 and 60, but we don't know what those 2 students exactly got. We know 6 students got between a 91 and 100, but we don't know what each student actually got. So you can't tell that information from a histogram. Now the keystone might include something about mean absolute deviation. We are not going to spend a ton of time on it, but the mean absolute deviation is basically another way to measure variability. So it's basically the mean distance a number is from the mean. So if we look at this example, which will be pretty quick, Kayla earned the following scores on her 5 tests in science. So what we would do first is find the mean. So you add up all the numbers, divide by the 5 scores, and this is our mean, this is our average, 78. What you then do is take each of the scores, so 70, 90, 80, 80, and 70, and you subtract 78 from it. So when you're doing this, you're going to subtract 78, which is the mean from each number, but just make sure that if it's a negative, just turn it positive. That's where it's called mean absolute, meaning keep it positive. So like 70 minus 78, you just take the absolute value of that and then you get positive 8. Basically, this is just meaning that the first quiz score is 8 away from the mean. For 90, that's 12 away from the mean. 80 is 2 away from the mean, so is the other 80. 70 is 8 away from the mean. You get these numbers now, and you find the average of those. So then you add up all of those numbers here. You divide by how many there are, which is always going to be the same number, 5, and we get 6.4. So 6.4 is the mean absolute deviation, which just says on average, the data varies 6.4 percentage points away from the mean. So that's how that works. We're not really going to do a lot with it because I haven't really seen the Keystone use mean absolute deviation in the questions recently, but that is what it is. If it was to pop up, hopefully you would remember this and think back. So next comes probability, which I will start a different video for that.